This is the same question from the previous video, and what we're going to do this time is solve this using algebra. If you remember, we've got 5% methanol to be mixed with 12% methanol, and that's going to come out to a mixture of 1,000 liters containing 10% methanol. We had filled in this blank spots with X and Y. Those represent how many liters of each methanol mixed, and we came up with two equations. One of the equations was the quantities, X plus Y equals 1,000, and the other equation put everything together. 5% X plus 12% Y, 10% times 1,000. That equation represents how much methanol is in each mixture. We had solved for Y, so Y was 1,000 minus X, and we did that previously because that was easier to set up a table of values for graphing. In the second equation, we had figured out what this 5% was as a decimal, the 12% as a decimal, and 10% times 1,000. And then we had solved for Y, so we had moved the 0.05x to the other side, and we had divided it by 0.12. This time we're not drawing a graph, we're using the equations, and that way we are going to be able to get an exact answer for X and Y. Using the graph was just a guess. So to solve for the X and Y, what we're going to do is we're going to set these two equations equal to each other. 100 minus 5x. We can do that because both of them are equal to Y. This second equation is kind of awkward because it has this fraction approach, some stuff on the top divided by 0.12. So what we need to do is separate that to remember from fractional equations. It'll be a lot easier if we separate this, because then we can move x's to one side, numbers to the other side. I think I'm going to move the x's over to the left side. So we already have a minus x there. And we want to move this 0.05 divided by 0.12x, and it's a minus right now. So when you move it over, it's going to change to a plus 0.52x equals. On the right-hand side, we've got our 100 divided by 0.12. And on the left side, we have this 1,000. It is attached to the x by a minus sign, but you're not going to look at that. You're going to look at whatever is in front of the 1,000. There's nothing there, so that means this is a positive 1,000. So when we move it over, it's going to be opposite, so it's going to be minus 1,000. Okay, I want an exact answer, so I'm going to be using fraction buttons on my calculator. On the first part, I've got a negative x, so that's a negative invisible number 1. So on my calculator, -1 plus decimal 0.05 fraction decimal 1/2 and I'm hitting equals, and I'm getting -7/12. So -7/12 x equals, now on my calculator, 100 fraction decimal 12 minus 1,000. And I'm getting -166 2/3. So now I'm going to solve for x. And this -166 2/3 on my calculator, I'm going to be working with that and the -7/12. The -7/12 is attached to the x by a multiplication. So I'm going to be dividing by -7 fraction 12. Remember, do not change the sign of anything. We're dividing. So divided by -7/12. And now I'm really going to be going for decimals. So on my calculator, I got a big long decimal, and I'll pick one decimal place, 285.7, and that would be liters. Now to solve for y. Y equals, well, let's go back and look at the equations. And we have two equations to work with. We have the y, 1,000 minus x, and we have y, a big, huge equation. I'm going to go for this simpler one right here, 1,000 minus x. So 1,000 minus x, that'd be 1,000 minus, and for x we got 285.7. So on my calculator, I'm working out 1,000 minus 285.7, and I'm getting 714.3. 714.3, and that would be in liters. So that's an exact answer of how much of each mixture we need. 285.7 liters of the 5% mix and 714.3 liters of the 12% mix.